Hello everyone, welcome to my channel Science Quickly. In today's video we are going to talk about velocity. Velocity means, in short, velocity means displacement, which is s divided by the time. Okay, so what by definition we can say that velocity is the rate of change of displacement. Velocity depends on two things. Okay, first of all, let's see what is the unit of velocity and what are the symbols for velocity. Velocity has two symbols, u, small u, and a small v. If we are talking about the initial velocity, we use a symbol small u. And if we are talking about the final velocity, we use a symbol small v. Initial means at the starting of the motion and final means at the end of the motion. So there are two symbols for velocity. Velocity is also a vector quantity. Remember, displacement is a vector quantity, so velocity is also a vector quantity. Now let's figure out what is the unit of velocity. Let's say velocity equals to displacement upon time. The SI unit of displacement is meters and the SI unit of time is seconds. So the SI unit for velocity equals to meters upon second. Of course, we can also have a bigger unit. Sometimes we'll use kilometers per hour. You can also have centimeters per second, etc., etc. So these are the other units of velocity. Now, velocity, when we say it is a vector quantity, that means we have to mention what is the direction of the velocity. So velocity has two important things. Firstly, speed, and secondly, direction. So let's try to figure out what it means by velocity depends on two things, speed and direction. For that, let's start with one example, which we are going to, let's start with non-uniform velocity. Now, what is non-uniform velocity? Remember what we said earlier, velocity depends on two things, speed and direction. In a motion, if any one of the quantity changes, if the speed changes or if the direction changes, we call those kind of motion as a non-uniform velocity. Any one of them changes or both of them changes, we still call it as a non-uniform velocity. Let's take an example to understand this. Let's start with speed. Say suppose a car is going from point A to point B, point A to point B, and then it starts from point B and goes to point C. Oh, sorry. It starts from point B and goes all the way up to point C. Sorry, my bad. Okay, and goes all the way up to point C. Now, what we are saying is that if the speed of the car from A to B was 50 meters per second and the speed of the car from B to C was 60 meters per second, the direction is always going from left to right. A to B may be left to right ja raha hai. And from B to C also the direction of the car is going from left to right. So the direction of the car never changes. So in here, one condition is already satisfied. Direction of the car never changes. Now let's look at the speed. From A to B, the speed of the car is 50 meters per second. And from B to C, the speed of the car is 60 meters per second. The speed of the car changes. That means it is a non-uniform velocity. So we'll consider this example as a non-uniform velocity. Let's take another example. A car starts from point A and goes to point B. And from point B, it goes to point C. So let me just label everything so we are clear about this. We are going to start with point A. It goes all the way to point B, and from point B, it goes to point C. The speed of the car from A to B is 50 meters per second, and the speed of the car from B to C is 50 meters per second. Now, in this example, we can clearly see that the speed of the car never changes. The speed of the car is same, 50 meters per second, 50 meters per second. But let's look at the direction of the car. From A to B, the direction is going from left to right, and from B to C, the direction is going from bottom to top. So the direction of the car changes. So we call this kind of a motion as non-uniform velocity. The last case, what we are going to talk about is, let me just make a small change in this example over here. Okay. The car is traveling from A to B 50 meters per second, and it is going from B to C at 150 meters per second. Now, in this case, if you see, the direction changes and the speed also changes. So again, we call this kind of a motion as a non-uniform velocity. So just to revise everything, velocity depends on two things: direction and speed. If either one of them changes, or if both of them changes during a motion, we call those kind of velocity as a non-uniform velocity. So now that we have talked about non-uniform velocity, let's try to figure out what is a uniform velocity. Again, we'll take the same car example. A car starting from point A goes to point B. Car starting from point A goes to point B. The direction of the car is from left to right. And let's say the car is traveling at 50 meters per second. Of course, that is a lot of speed for a car, but we're going to assume that it travels with 50 meters per second. So if you think, in this case, the direction never changes. It is always going from left to right. The speed of the car also never changes. It is always 50 meters per second. So this kind of a motion where the direction does not change and the speed does not change, we call these kind of motion as uniform velocity. Now let's take one more example to just understand what it means. A person starts from his house and he goes to his school by taking this road. He goes to his school. Now, if you say this is the real path, of course, this is the real path. That means this is the distance. Now, if you think about it, in this case, when a person is traveling on the road, the speed will never be same, or it will never remain constant. Speed will constantly keep on changing. If there is traffic, speed will decrease. If the road is empty, the speed will increase. So the speed of this person will keep on changing. If the speed of the person changes, then we say that the person is traveling with a non-uniform velocity. If the speed remains same, and if the direction changes, then we say that the person is traveling with a non-uniform velocity. So if you consider the whole motion from house all the way up to school, we call it as a non-uniform motion. Now, if I talk about a small period of time, say from here to here, let's say that the speed of the car in this part from here to here is 50 meters per second. From here to here, the speed of the car is 60 meters per second. Sorry. Okay, so the speed of the car is 60 meters per second. Now, if you consider the whole direction over here, the speed changes. So we say it is traveling with a non-uniform velocity. That is fine. So we call it as a non-uniform velocity. Now, if you take only the short period of time from here to here, this is the starting point. So this will be my U, and this is the ending point. This will be my V. In both the cases, U is equal to V, and the direction of the motion also never changes. So in that case, we say that the body or the car is traveling with a uniform velocity. Now let's look at the another type of velocity, which we call it as average velocity. So let's try to figure out what is average velocity. Again, let's take an example of a car traveling from point A. It goes all the way up to point B. Okay. The displacement. Now, for this, what we are going to consider is that everything is traveling in a straight line. Okay, so there is a car traveling in a straight line. It starts from point A and it goes all the way up to point B in a straight line. So this is my ending point B. Now, if you think about it, the direction never changes. It is always going from left to right. So we don't have to worry about the direction of the car anymore. All we need to worry about is the speed of the car. Okay. Now the person, or let's say this car starts from point A and the total distance from point A to point B is 300 kilometers. The person starts at 6 a.m. in the morning and he reaches the destination at 12 p.m. So basically it took him total time of traveling equals to 6 hours. Now during this 6 hours, this person can be traveling at some point, he might be going 120 kilometers per hour. At this point over here, just imagine he had stopped for a tea break. So his speed over here was 0 kilometers per hour. Again, he found that the road was pretty empty over here, so he was driving at 120 kilometers per hour. So again, this motion is an example of a non-uniform velocity. Now let's try to figure out what is average velocity. Average velocity. Average velocity equals to total distance or displacement is exactly same because everything is moving in a straight line. So total distance traveled divided by total time. Now remember one thing, distance and displacement are exactly same because everything is moving in a straight line. So you can say either of them. So let's find what is the average velocity of this car. The total distance traveled is 300 kilometers and the total time taken is 6 hours. So The average speed of this car is 50 kilometers per hour. Doesn't matter if he was traveling at 120 kilometers per hour, he took a tea break where the speed was zero. We say that the average speed of this person is 50 kilometers per hour. That is known as the average velocity. The last thing is instantaneous velocity. Instantaneous velocity. What is instantaneous velocity? Velocity at a given instance is known as the instantaneous velocity. So if I look at the velocity of this car during this time period, this short time period, we can say that the velocity of the car was 120 kilometers per hour going from left to right. So the instantaneous velocity is 120 kilometers per hour. Now the positive sign over here, this is plus 120, which shows that the car is moving from left to right. If I look at this instance over here, when the car has stopped for a tea break, the instantaneous velocity would come to 0 kilometers per hour. Now, of course, the velocity is only considered for that short period of time when it is 0 kilometers per hour. And again, after that, if I see the velocity of the car at this position over here, it was again 120 kilometers per hour. So instantaneous velocity is the velocity of a car at the given instance. So when you are driving in a car, and if you look at the speedometer of a car, the speedometer of a car tells you what is the instantaneous velocity, or we can say instantaneous speed of that car. What is the velocity at that moment? That is known as instantaneous velocity.